In this question, we're given a graph which shows information about the time in minutes that a liquid has been cooling and the temperature of the liquid in degrees Celsius. And in part A, we need to work out the temperature of the liquid at time 2 minutes. We need to use our graph to be able to do this. We can start by drawing a vertical line upwards from the point at which the time is equal to 2 minutes. Now we need to use our graph in order to find the temperature at the point when time is equal to 2 minutes. And so we can draw a horizontal line across from our graph. And so using our graph, we found that the temperature of the liquid at the time when t is equal to 2 minutes is equal to 80 degrees Celsius. Now Pam recorded the time when the liquid had a temperature of 50 degrees Celsius, and we need to write down this time. We can apply the same principle to part B as we did in part A, except this time we already know the temperature instead of the time. And so using our graph, we can draw a horizontal line where the temperature is equal to 50 degrees Celsius. Now we can draw a vertical line downwards from the point at which our first line touches the graph. And so using our graph, we can see that when the temperature is equal to 50 degrees Celsius, the time is equal to 8 minutes. We're now told that Pam says that the temperature of the liquid drops more in the first 3 minutes of cooling than it does between the time 9 minutes and the time 12 minutes. In part C, we need to find out whether or not Pam is correct, giving a reason for our answer. Now part C is about the rate of cooling, and the rate of cooling is represented by the gradient of the graph. And so if the temperature of the liquid drops more in the first 3 minutes of cooling than it does between the time 9 minutes and the time 12 minutes, we can say that the rate of the change in temperature in the first 3 minutes would have to be greater than the rate of the change in temperature between 9 minutes and 12 minutes. And in graphical terms, this means that the gradient in the first 3 minutes would have to be greater than the gradient between 9 minutes and 12 minutes. So let's take another look at our graph. Now this is our graph in the first 3 minutes. And now this is our graph between 9 minutes and 12 minutes. And so we can see that the gradient in the first 3 minutes is much steeper than the gradient between 9 minutes and 12 minutes. And so we can see that the rate of the change in temperature is greater in the first 3 minutes than it is between 9 minutes and 12 minutes. And so we can therefore say that Pam is correct because the gradient is steeper in the first 3 minutes and less steep between 9 and 12 minutes. And so therefore the temperature of the liquid drops more in the first 3 minutes of cooling than it does between 9 minutes and 12 minutes. Now this question is worth 3 marks. We get the first mark for finding that the temperature of the liquid at time 2 minutes is equal to 80 degrees Celsius. And we get the second mark in part B for finding that the time is equal to 8 minutes when the liquid had a temperature of 50 degrees Celsius. And finally, we get the third mark in part C for saying that Pam is correct because the gradient is steeper in the first 3 minutes and less steep between 9 and 12 minutes. Allowing us to get the full 3 marks needed in this question.